Hello, everyone. Welcome back. Today, we're going to talk about solving polynomial inequalities. So, this has to do with, rather than just linear inequalities, actual polynomials. So, I want to illustrate what I mean by that with example one here. It asks, here's a graph. Find the intervals where f of x is greater than 0. Well, let's see. Let's see. Well, here's the 0 line right here, this x-axis. Where is f of x greater than 0? Well, it's greater than 0 for this little hump, and it's greater than 0 for this line right here, right? For this, well, I shouldn't say line, but for this part of the graph over here. And where is that? That means from -4 up to -2, it would be greater than or equal to 0. So let's put those numbers in. And also from 1 to infinity, right? Because here's 1 and it just goes up to infinity forever. Um, those are the intervals where f of x is greater than 0, or greater than or equal to 0, I should say. B asks, find the intervals when f of x is greater than or equal to g of x. So now we're not comparing f of x to the x-axis line, we're comparing it to g of x. So here's g of x, it's this line here. So it is from there to there, and then it goes below, and then right here it goes above again. So where are those points? Well, it looks like this one is around -5, and then it stops around, -1 is where it stops. And then it starts up again, being greater than, greater than this g of x line over at 1 again. So therefore, the intervals would be from -5 up to -1, including those values as well, because it asked it didn't ask when are we strictly greater than g of x, it's just asked when we are greater than or equal to g of x, right? And then also from 1 to infinity. Because right here, all three intersect. The x-axis, g of x, and f of x all intersect right there. And so I know, this part looks similar. The second one looks very similar to, this one here, but that is correct, and that's why. So there we go. So essentially, when we're solving algebraically, this is what we're really asking. We're really asking, when is this polynomial greater than or equal to or less than or equal to, or whatever the case is, some other polynomial? What values is that possible for? Now, with linear inequalities, we know that there's only really one place, right? It's only from this place to that place, or something like that. It's usually a lot more simple. With these ones, there can be multiple times when something is greater than for a bit, and then it's less than, and then it's greater than again, and then it's less than again, and so on, right? We can have more complex situations like that when it comes to polynomials with a higher degree than just polynomial degree 1, which is essentially what we talked about last day. Okay, so with all that in mind, let's try example 2. Example 2 says solve the inequality using set notation. Okay, so how are we going to solve this inequality? Well, here we want to know where we're greater than or equal to 0. So the thing is, in order for this to be greater than or equal to 0, it needs to be part of an interval where we've crossed 0, right? So if we find the zeros, we found the boundaries. So first of all, let's talk about, well, when would this polynomial be exactly equal to 0? Well, it would be equal to 0 during the x-intercepts, which are 0, 4, and -3, right? Those are the 3 times it's going to be exactly equal to 0. And for it to switch from a positive interval to a negative interval, or in other words, for it to switch from being for the polynomial to switch from being less than 0 to greater than 0, or vice versa, it would have to cross one of these x-intercepts to do that, right? And so those are our boundaries. So let's write down what are all the boundaries in this case. Well, we have the boundary from -infinity up to -3. That's our first one, where it's either going to all be negative or all be positive, because in order for it to switch from positive to negative or negative to positive, it has to cross this boundary, right? And then what about at x equals to 3? Or sorry, x equals to negative 3. In this case, it's exactly 0, right? Okay, what's our next interval? It's from negative 3 to 0, right? Because that is our next place on our graph. That's from the next 0 to the next one. And then we have when x is exactly equal to 0, y is 0. And then from 0 to 4. And then for x equals 4, we have 0 again. And then we have from 4 to infinity. So those are the intervals we have. And keep in mind, the reason why I chose these intervals specifically, it wasn't just random, right? It was, here's where x-intercepts are, and that's where this function has the opportunity to switch from being greater than 0 or less than 0. So what happens when our function is anything from negative infinity to negative 3? Well, let's just choose a number in this interval, like negative 4. If we plug in negative 4 to our original, what will we get? We'll get negative 4 times negative 4 minus 4 times negative 4 plus 3, which is equal to negative 4 times negative 8 times negative 1, which is negative 32. So there we go. Okay, so negative 32 is a negative number, which means this entire inequality is less than 0, right? This entire thing is a negative interval, meaning that it's less than 0. Now, you might be saying, well, but we only tested for one number. We only tested for negative 4. How do we know it's true on the whole interval? Well, because in order for the interval to switch from negative to positive or positive to negative, we have to have a 0 there. And the first 0 we have, the first x-intercept we have is negative 3. So if one of the points before negative 3 is, below 0, that means that entire interval, it must be below as well. Okay, and now we have x is negative 3. So now from negative 3 to 0, from one 0 to the next, from one x-intercept to the next, we do now have the opportunity for it to go positive suddenly. So now let's check one of these values here from negative 3 to 0. Let's check negative 1. If I plug in negative 1 into this equation, I'll get negative 1 times negative 5 times positive 2, which is going to be positive 10, I believe, or at least it's going to be something positive because we're multiplying a negative, and a positive, which is going to give us something positive. So this interval must be positive. And for the same reason, because it's positive on one point of the interval, it must be positive throughout the entire interval, right? Because in order for us to switch, we would have to have another 0, and we don't have another 0, or in other words, another opportunity for this to switch, whether it's positive or negative, until after x equals 0. So after x equals 0, we have another interval from 0 to 4. So I'm going to choose a number from this interval to plug in to see if the entire interval is positive or negative. So I'm going to choose 1. So that's going to give me 1 times negative 4 times positive 4, which is negative 16. So that means it's negative. So there we go. Okay. And then we have, for x equals 4, we have 0 as well. So that's good. That's very good. And then after 4, we have another opportunity for it to flip again, for it to, go from positive to negative or negative to positive. So let's try that. What if we plug in 5? We're going to get positive times positive times positive, right? This one would be positive if x is 5. This would be positive if x is 5. And this would be positive if x is 5. So therefore, we get something positive. So now the question is, which intervals do we actually want? Well, we want the positive ones because we wanted to know where is this equation greater than or equal to 0, which means where is the equation positive? That means that it is positive. It is the intervals we want are this one that's positive, this one that's positive, also this one's included, and this one's included because it said not just greater than 0, greater than or equal to. So when I write my final answer, I'm going to say that we're going to include -3, and we're going to include 0, and we're going to include 4. So I know I wrote these with square brackets, but that's to show that we're including those as well. We're including everything that's not negative. The only things I'm not including here are examples, are the intervals where it is less than 0. Any times when it's equal to 0 or greater than 0, right? Any positive intervals or 0 points are included here in my answer. Oh, they said using set notation. Oh, I used interval notation. Okay, well, that's okay. I'm going to change it to set notation then. In set notation, this would be from -3 to 0, including those points, and when x is greater than or equal to 4. All right, and there we go. We fixed it. We wrote it in the notation they liked better for this one. Okay, let's try this one using set notation. So this one is very much the same thing, right? This is very much the same method as before. This time, actually, I'll use set notation all throughout. I want to give an example where I do use set notation all throughout. So it's going to be the same it's going to be the same problem, but this time I'll just use all throughout the question, just set notation. Okay, so first of all, what are x-intercepts? So our x-intercepts are going to be x equals to 2, x equals to a half, and x equals to 5. Awesome. Okay. So that means that our first interval is going to be any time when x is less than a half, okay? So that's my first thing I'm going to write is x is less than a half. Then we have x is equal to a half, which comes next. And that means y is 0. Then we're going to have something between a half and 2. And 2. And then we're going to have where x is equal to 2. And that's going to be 0 because as we know, that's an x-intercept. And then we're going to have the interval from 2 to 5. And then we're going to have the when x equals to 5. I'll get rid of this. Okay. So this is from the last one. And then we're going to have where x is greater than 5. Okay. So now we have to figure out, are these intervals positive or negative? Or in other words, which ones are positive or negative? So what if x is less than a half? Oh, I wrote x is greater than a half. My apologies. I meant x is less than 1/2. Let's make that clear. The only one that should be greater than would be the last one, which is x is greater than 5. I didn't mean to write greater than for that one. Everything else should be less than. Okay. So x is less than 1/2. If x is less than 1/2, let's say it's 0. Let's just choose an easy one. If x is 0, then what is our answer going to be? Well, we're going to have 2 minus 0, which is 2. So we're going to have a positive number times 2 times 0 minus 1, which is a negative number. So positive times negative. And then 0 minus 5 is also going to be -5, which is a negative. So we have a negative and a positive and a negative, right? And so we're going to end up with a positive. So plus is our answer here. What about between 1/2 and 2? I'm going to choose 1. If I put in 1 into my original equation, I'll get 2 minus 1, which is 1. So we'll get a positive. 2 times 1. Did I do that one? Sorry, 2 minus 1, which is positive. 2 times 1 minus 1, which is positive as well. And then 1 minus 5, which is -4, which is negative. So positive times negative gives us a negative. So this will be a negative interval. Then we have where x equals 2 is 0 again, right? Because that's an x-intercept once again. And then we have the interval from 2 up to 5. So I'm going to choose 3 to plug in here. If I plug in 3, 2 minus 3 is -1, so that's a negative. 2 times 3 minus 1 is 6 minus 1, which is 5, which is a positive. And then 3 minus 5 is a negative. So I have a negative times a positive, which gives me something positive. And then when x is greater than 5, we're going to end up with 2 minus 6, let's say. Let's just choose 6. 2 minus 6 is negative 4, which is a negative. Then we have 10 minus 1, or sorry, 12 minus 1, which is 11, which is a positive. And then 6 minus 5, which is also a positive. So we have two positives times a negative, which means the entire interval is negative. So therefore our answer is what? Our answer is all the positive intervals and the zero intervals. So everything that's not negative is included here. So therefore the answer is when x is less than or equal to a half, and when x is between 2 and 5, including the values 2 and 5. So there we go. Awesome. All right, let's do some more. This next one says, solve the inequality using interval notation. So you might notice, well, hey, this is not in factored form. So how do we do it? Well, we've got to make it into factored form then now, don't we? So how do we do that again? Well, we used the steps from a couple lessons ago that we already used. We first need to figure out what this is divisible by. So let's see, if I plug in 1, will that work to get us a 0 remainder? No, that won't work. What about if it's 2? Well, I don't think that'll work. No, maybe it will. Actually, I think it will. Let's try it. What is f of 2? That's going to be 2 times 2 cubed minus 2 squared minus 5 times 2 minus 2, which is equal to 16 minus 4 minus 10 minus 2, which is just 16 minus 16, which is 0. So therefore, x minus 2 is a factor. So now we're going to use our long division to figure this out. So 2x cubed minus x squared minus 5x minus 2. And then we have x minus 2 out here. Okay, so how many times does x go into 2x cubed? 2x squared times. So x times 2x squared is 2x cubed. And then we have negative 2 times 2x squared, which was negative 4x squared. And then we're going to subtract, and we're going to end up with negative x squared minus negative 4x squared, which is positive 3x squared. And then we're going to bring down the negative 5x. Okay, and now how many times does x go into 3x squared? Well, 3x times. So we got 3x squared, and then here minus 6x. And then we're going to subtract, and we're going to get x. And then we're going to bring down the negative 2. How many times does x go into x? Well, 1 time. Then we multiply it out, and we get x minus 2. So remainder is 0. Now, let's say we didn't get remainder 0. That would be a big problem, because that would mean that our remainder theorem answer was not consistent, and we either made a mistake with the division or a mistake after the division. Okay, very good. All right, so let's move on. Let's move on to the next part. So the next part is going to be to say, well, x minus 2 times 2x squared plus 3x plus 1 is greater than or equal to 0. So we're just taking this, our original, and we factored it once. We factored out an x minus 2 by doing that whole process. Now we just have a quadratic left, so we already know how to factor quadratics. So we can say this is going to be 2x plus 1 times x plus 1 just by using the factoring method we already know for our quadratics. Okay? Then we're going to say, well, where are our boundaries? So let's now do the thing we just learned today, our new thing, which is to say that the x-intercepts are 2, negative a half, and negative 1. Okay, so in that case, we are going to have our first one be, here they want interval notation. That's great because I think interval notation is much better anyway than set notation. It's just a preference, though. They're both perfectly valid in actuality. But our first interval would be from negative infinity up to negative 1. And then we would have equaling negative 1. And then we would have from negative 1 up to negative a half. And then we would have x equals negative a half. And then we would have negative a half up to 2. And then we'd have equals to 2. And then we would have from 2 to infinity. Now we already know the answers for some of these. Remember, we already know the answers for all the x-intercepts, that they're just 0, 0, 0. We want to figure out, are these positive intervals or negative intervals? And then we're going to just choose the 0 and positive intervals in the end, because this sign says greater than or equal. They want to know when is it greater than 0 or equal to 0. They don't want to know when it's less than 0. Okay, so keeping that in mind, let's plug in something from negative infinity up to negative 1. So let's plug in negative 2 here. If we do that, we are going to end up with something negative overall, so negative. What about something from negative 1 to negative 1/2? So something like negative 3/4, which is an awkward number. But if we do that, we're going to end up with something positive there. Okay, so plus. Then what about from negative a half to 2? I'm going to just choose 0, and that one's going to be easy. We're going to get negative 2 times 1 times 1, which is something negative. And then from 2 to infinity, I'll choose 3, and we'll just get plus, 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 which is, of course, positive. So therefore, the answers in interval notation are which intervals? That's going to be this one here, this one here, because these are all zeros, right? And then this one here and this one here are positive. So everything that's non-negative, I'm going to give as the answer. Okay. And then we have negative 1 up to negative a half, including those numbers this time, and everything from 2 up to infinity. And there we go. There we have it. Okay. Next, let's do example 5. It says solve the inequality for x cubed plus 9x squared plus 23x plus 15 is less than 0. So this one is slightly different because this time we're only going to choose the negative intervals. So far we've just chosen positive and 0. This time, since we're looking for when this equation is less than 0, we're just going to choose the negative intervals, and those are going to be our only answers for this one. Okay, but first of all, we have to figure out how to factor this so we can even figure out where are our boundaries and what should we even look for in order to determine which intervals we can really do here. So let's do that first. Okay, so f of negative 1 I think would work. Yeah, because 1 wouldn't work. These are all positive, but I think f of negative 1 might work. So let's try it. F of negative 1 is negative 1 cubed. And then we have plus 9 times negative 1 squared plus 23 times negative 1 plus 15. Okay, so let's see if that works. That's going to equal negative 1 plus 9 minus 23 plus 15, which, that is 0. Excellent. So therefore, x plus 1 is a factor. And there we go. Okay. Alrighty. So now that we know that x plus 1 is a factor, we've got to actually do our long division. So let's do our long division. X plus 1, x cubed plus 9x squared plus 23x plus 15, like that. Okay, how many times does x go into x cubed? Well, x squared times. Then we subtract and we get 8x squared. We bring down the 23x. How many times does x go into 8x squared? Well, 8 x times. And then we get 8x squared plus 8x, and we subtract. And then we get 15x, and then we bring down the plus 15. And then how many times does x go into 15x? Well, 15 times. And we do get remainder 0, which is good because if we didn't, that would be inconsistent with what our factor theorem told us. So that would mean we did our long division wrong, or we plugged in something wrong with our factor theorem, or did some calculation wrong somewhere. So now we have x plus 1 times x squared plus 8x plus 15 is greater than, or sorry, is less than 0. And then I need to fully factor this, so I need to do x plus 1, and then I need to figure out two numbers that add up to 8 and multiply to 15, and those numbers are 3 and 5. So therefore, our x-intercepts are x equals -1, -3, and -5. And they also want interval notation here as well. So our first interval is going to be from -infinity up to -5. Beautiful. Then we're going to have x equals to 5, or sorry, x equals to -5. Then we're going to have the interval from -5 up to -3. Then we're x equals to -3, then the interval from -3 up to -1, then x equals -1, and then -1 to infinity. So there we go. We did it. Okay, so we know all these ones are 0, 0, 0, but what about in between? So what about between -infinity and -5? So something like -6, we would get negative, 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 negative times negative, which is indeed negative, so minus sign there. What about from -5 to -3? Well, let's choose -4. The first two would be negative, but 5 minus 4 is 1, which is positive. So overall, we'd get negative times positive, which is positive. What about from -3 to -1? Let's choose -2. We'd end up with a negative for the first one. So -2 plus 1 is -1, times 3 minus 2, which is +1, times 5 minus 2, which is 3. And so that's going to end up being a negative times a positive, which is negative. And then last but not least, anything from -1 to infinity. Let's plug in x is 0. We would end up with 1 times 3 times 5, which is definitely a positive number. So what did the interval want? They wanted everything that was less than 0, so all negative intervals. And it's strictly less than 0, not less than or equal. So it's only going to be this one and this one, and those are the only two answers. And because we're not including the equals, the only answers here are -infinity up to -5 with a round bracket, not a square one, and -3 up to -1 with a round bracket, not a square one. Up here we use square brackets in this case because it was greater than or equal. This one is just strictly less than. There's no less than or equal or greater than or equal sign. No, it's a strict less than, and therefore we're only choosing the negative intervals in this situation. Okay, let's do, I know this is getting kind of long, but example 6 is actually slightly different here. And it's our last one, so we're going to go ahead and do example 6 now. So it says f of x is equal to 3x cubed minus 3x squared minus 2x, and g of x is equal to 2x cubed minus x squared plus x. Find where f of x is greater than g of x. So let's do that. Let's find where f of x, which is this, is greater than g of x. So 2x cubed minus x squared plus x. Okay, so what I'm going to do is I'm going to bring everything to our left. Okay, so then I'm going to have x cubed minus 2x squared minus 3x is greater than 0. And then I'm going to factor this. Oh, and there's actually, this is good news. Okay, we don't even have to do our long division at all. I'm just realizing, and I'm getting excited that we don't have to, because we can just do this. We can common factor out x, and then we can factor this quadratic and say, what are two things that multiply to negative 3 and add up to 2? Well, negative 3 and 1, so x minus 3, x plus 1, that will work. And then there we go. There we go. We already factored it. We're done the factoring part, which is great. No long division required. Now, we could use long division if we wanted, but what's the point? If we don't have to, my advice is if you don't have to, don't do it, because it takes a long time, right? You saw how long it took us to do the other two. This is much faster. Okay. So now, what are our x-intercepts? They are x equals to 0, 3, and negative 1. So therefore, what are intervals? In this case, actually, it didn't tell us whether we should use interval notation or set notation. So when it doesn't tell you, you can use either one, because the question should specify if they want a certain format. Okay, so the first interval is from negative infinity up to negative 1. Then we have where x equals negative 1. Then we have from negative 1 up to 0. Then we have where x equals 0. Then we have from 0 to 3. Then we have where x equals 3. And then we have from 3 to infinity. And we know already that where x equals 0, negative 1, and 3, we have 0, 0, 0. There we go. So it's the other intervals we've got to figure out. So what if we have something from negative infinity to negative 1, like negative 2? Well, then that would be negative 2 times negative 5 times negative 1. So negative times negative times negative is indeed negative. So there we go. Then what about from negative 1 to 0? So something like negative a half would be a negative number times a negative number times a positive number, because 1 minus a half would be positive a half, which is positive. So we have negative times positive, which is overall positive. Then what about from 0 to 3? So let's choose something like 1. We'd have 1 times 1 minus 3, which 1 minus 3 is negative 2. So positive times 1 plus 1, which is 2. A positive again, so we would have negative. And then we have from 3 to infinity, which is going to be positive, right? If I put something like 4 here, we're just going to get 4 times 1 times 5, right? We're just going to get positive, 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 which is positive. Okay, so we want to know, where is this greater than 0, right? Where is f of x greater than g of x? Since it's strictly greater than, I'm only going to choose my positive intervals. I'm not going to choose anything that's equal to 0 or anything that is a negative interval. So just these two. So therefore, f of x is strictly greater than g of x when we have from negative 1 to 0 and from 3 to infinity. So there we have it. Very good. All right. Well, that is it for today. Good work today, everyone. And I will see everyone for the next lesson. Bye, everyone.